So when we look at the types of batteries that are available, we have coin cells, pouch cells, cylinder cells and prismatic. However, the processing stages, regardless of what cell type you're manufacturing, can essentially be broken down into 6 stages. These are mixing, coating, calendaring, slitting, stacking and sealing. Today we're going to focus on coating techniques, and that in itself can be broken down into 3 stages. The first of these stages is to use a known material. This is in order to validate the cell building techniques, and you would use a pre-coated electrode sheet from our supplier NEI. These are available to support both lithium and sodium research technologies, and the material is coated onto an aluminium foil for the cathode or a copper foil for the anode, and it can be provided in either single or double-sided coating depending on your research application. By using a pre-coated electrode, we have predefined specifications that these adhere to. We can then use these when we come to manufacturing our own electrodes as a reference position. The second stage we move on to is to then produce your own electrode sheets based on the known chemistry that we've validated from stage 1 using the pre-coated sheets. In order to do this, we need to coat a slurry consisting of the active powders, binders and additives, which are available from our partners at NEI, LTS and MTI. So to coat the slurries onto the foils, we would use either a flatbed coater or a roll-to-roll coater. Both of these are available from NTI. Now, we have a wide range of coaters available, ranging from the smallest ones which fit into a glove box, and are used at the early stage research and small scale research in a laboratory, all the way up to pilot scale production, which is more the roll-to-roll versions that we would see. We'll focus at this time on the flatbed coaters. Now, most of these will have a vacuum chuck flatbed. This is where you would place the foil to be coated onto, and the vacuum will securely hold the foil in place while you're coating your slurry onto the foil. As well as the vacuum chuck, we have options for heating as well. Now, this can be bottom heating, top and bottom heating, and even ultraviolet heating if this is required. And this is just to aid drying and curing of the slurry once it is coated onto the foil. Doctor blade coating is the simplest and most common method of coating used in the early stages of research. The doctor blade is placed onto the flatbed coater. The slurry is then poured in front of the doctor blade, and this automatically passes over the foil at a constant speed, leaving behind a uniform layer of coating as it does so. The depth of the blade can be adjusted to have a certain amount of control of the thickness of the coating. However, other aspects such as the viscosity of the slurry will also have an influence on this. Typically with a doctor blade, you can get coatings as thin as 10 micrometers, depending on the type of material that you're using. As an alternative coating method to doctor blade coating, we can use slot die coating. Now the slot die comes with various shims, and this adjusts the thickness of the gap through which the slurry is fed and therefore adjusts the coating rate. The coating head is placed onto the flatbed coater much like the doctor blade, but this time the slurry is fed using a syringe pump, which is usually automated and dispenses a defined volume of slurry at a defined rate of dispensing for a defined time. The foil is placed onto the vacuum chuck, and at this stage you would turn on the vacuum pump and ensure that the foil is completely flat and free of wrinkles before you start the coating process. You would adjust here the coating speed which the coating head will pass over, and the length as well that you want coating. And if you have any temperature options, this is where you would turn these on and set the temperature at the correct rate. The syringe pump is then turned on, the coating head is started, and as you can see here, the coating head passes over the foil and leaves behind a uniform layer of coating. There is no contact between the foil and the die using a slot die coating method, and you have more control and the ability to coat thinner layers down to 5 micrometers. As we scale up our production, we will move away from the flatbed coating and we'll move towards a roll-to-roll coating method. Now, we can simply modify a flatbed coater and have an unwinder and a winder reel at either end, and use this to feed through a complete roll of material. However, what we normally find with the higher production rates and to gain access to a wider range of techniques are the larger machines which are available from MTI. Now, with slot die coating, we also have the ability to control the flow of the slurry through the slot die. And this allows us to provide either a continuous coating or an intermittent coating. Now with intermittent, we have the ability to print a defined pattern onto the electrode foil, and this can be used to align with the tab connectors that we need to weld on at a later stage. On some models, we also have the ability to reverse the roll and then coat onto the opposite side to provide a double-sided coating. Possible with some of them to integrate the hot or cold calendaring process, which further speeds up the overall manufacturing process for the foils. And then depending on the volume of foil that you intend to produce, we can have separate slurry feeders. Now these can hold up to 4 litres of slurry, so you can produce a very long run of production without any interruptions, and that ensures that you gain the continuity of the coating method. So once we've mastered the coating technique in stage 2, we can move on to stage 3. Now this is where we'll start using our new materials and novel chemistries to adjust the properties of the coating, which will be specific for each area of research. And look out for a future video where we'll be going into more details on the advanced materials we can supply. To summarise, electrode coating is crucial in battery manufacturing as it significantly impacts performance and reliability. The quality of the coating directly influences factors like conductivity, adhesion, and energy density, all of which are essential for a battery's lifespan and efficiency. At PI-KEM, we're proud to supply high-quality materials, consumables, and equipment. We also provide years of experience working alongside universities and research institutions. Whatever stage you're at, we're here to make your research smoother and more impactful. We'd love to hear about your project goals and see how we can contribute to your success. We're excited to work together and drive innovation forward.